Welcome to Brain Vision.
Okay, so problem 782, we have a segment of DNA is put in place and stretched. So there's a discussion in a text more about this, and the figure in the book looks much better than this. I just drew what it generically looks like, but we have force versus the displacement, but essentially this shows a straight line. And we have four options. Based on this graph, we're supposed to determine which statement is the best interpretation of the DNA's behavior or the range of displacements. Okay, so first option is that it doesn't follow Hooke's law and that the force constant increases as the force increases. So I wrote down what Hooke's law is. So we have F is equal to Kx. And then also K, those are just the two options that are description. I made a little table. And then for part B, it follows Hooke's law, and this is what K is. C is it follows Hooke's law, and this was what K is. D is it does not follow K's law, Hooke's law, and K decreases as the force increases. Okay, so first off, Hooke's law is an equation. We have the force is equal to some constant times x. And from our understanding of essential equations, of any equation, we know that K here is a slope because it is multiplied by x. And if we took a derivative of this, we would find that the slope of this function is K. So first off, it looks like K is constant. We have a straight line. The slope of K at each of these points is going to be the same because it's a line. So we have it definitely cannot be answer A or answer D because it does follow Hooke's law. Okay. Now what is that constant K though? So we can essentially just substitute in what our F and our X is at one of these points. So I'm going to plug in, we had 2 piconewtons, and then that corresponds to a point here of 20 nanometers. So if you substitute those in, we get K is equal to F over X. We get 2 piconewtons over 20 nanometers, and that gets us 0.1 piconewtons over nanometers. And that gives us answer B.